Nice, we're in.
Juan, you're up.
Excellent. All right. Good morning, everybody. Good morning. Hopefully, everybody can hear me and see me clearly. One thing I'm going to do is I'm going to spotlight myself for everyone so that everybody's able to see my screen fully because we will be showing a lot of close-up shots. This is going to be a really, really great presentation that we have put together for you. So good morning, everybody. Thank you so much for joining us this morning. My name is Juan Morales. I'm the Senior Staff Field Application Engineer for Smart HQ Pro here at GE Appliances. And the event where we are collaborating with Encompass. And today we're going to teach you how to diagnose a front load washer using the schematic diagram. All right, so this training is going to involve basically looking at the tech sheet, right, that comes included with that. So every time you go and work on any GE appliance, for the most part, we're going to have somewhere hidden within the panels or maybe behind a cover or something, there's going to be a tech sheet that is going to have how to get into the service mode, how to access fault codes, things of that nature. But it's also going to have the schematic diagram. Some of you know it as a wiring diagram. Whatever way you wish to call it, it's gonna be essentially what we're going to be talking about today. All right. So I do want to mention this is going to be an open conversation. At any point, if you have any questions about anything that I'm saying, please feel free to stop me, and I will be happy to pause and answer your questions because I'm sure there's going to be a lot of questions about what I'm going to be presenting today. All right. The other thing I do want to mention, my friends, is that with Encompass right now, okay, there is a promotion for you to be able to acquire the Smart HQ service application. And the reason why I'm bringing this up, my friends, I'm going to share my screen real quick over here, is because with Smart HQ, I'm just connected to a front load washer right now. You can actually access all these tech sheets that I'm showing you right from the app itself. So you would go to the manuals and bulletins, you would click on mini manual, and the schematic diagram comes right up here. And take a look at this, my friends. When we pinch to zoom, look at the crystal clear graphics that you get utilizing this platform here. So for example, if I wanted to check my water valves, there's my schematic diagram or the area in the schematics for water valves. It's really cool. So this gives you the opportunity to be able to get a lot of this great information. And of course, we want to make sure that you have access to all this. Okay, so we're going to go ahead and share our PowerPoint slide over here. And this this slide that you're seeing right now, this is the offer that Encompass has for acquiring Smart HQ service. And basically, if you scan that QR code, you will be able to purchase the Smart HQ service module, but it's also going to come with a 1 month of subscription to the service. All you'll have to pay is $199. But if you spend $2,500 in GE appliance parts over the next 2 months from the date of purchase, you will receive a $200 credit, essentially making this tool absolutely free. And I don't know all out there. This gives you the chance to basically get the tool, have it for a month. You get to keep the module itself for forever. The 1 month subscription after a month, it expires, and then if you want to renew it, not that you're going to get the money back. As long as you spend $2,500 in GE, goes like that. And again, we're going to show this. Go ahead and scan it right now. All right, with that said, my friends, let's go ahead and get right into the presentation. And the first thing we're going to talk about is the benefits of understanding schematic diagrams. Okay, so I'm going to dive right into this. This is going to be, again, probably one of the fastest hours that you are going to go through, right? The time is going to fly. Before you know it, it's going to be, wow, it's already like 9 a.m. Eastern time, of course. Because the information that we're going to share here, you're going to be able to take it as soon as you're done today. You're going to be able to take it to the field. And if you have a front load washer, use it. Use everything that I'm telling you. Troubleshooting is the easiest way to diagnose, and it's going to save you a ton of time. So with that said, let's dive right in. So what's the first benefit of understanding schematics? Well, accurate diagnostics, right? Because with schematic diagrams, you're able to pinpoint the root cause of a failure and actually reduce your troubleshooting time. So a lot of technicians I talk to out there, my friends, they say to me, "Hey Juan, it's much if I have a problem, just swap out the part, go in and give it a go." A lot of the times it works. And yes, that might be the case in some situations, but as you'll see later on, when we troubleshoot a no spin, no agitate condition on a front load washer, if you troubleshoot, believe me, you're going to save yourself the heartache of having to order multiple parts and make multiple trips. So while in some situations, if you know the symptom and you swap out the part and it fixes it, that may work. In most cases, you are, believe me when I tell you this, as a technician for many, many years, I can tell you troubleshooting will, in the long run, take a ton of time. Obviously, we also benefit from is correct parts replacement because, as I mentioned before, swapping out one part might fix it, but what if it's not the part? What if it's the main board or a wire harness? So again, accurately diagnosing is the best way to go. Also, safe service practices, right? With schematics, you're able to identify any circuits that may be live or high voltage, and you can protect yourself, but you can also prevent accidental damage to the unit. And I'll give you a great example when we dive into the DC circuits in a minute here. And the last thing, my friends, is consistent workflow. Okay, so using schematic diagrams allows you to establish a standard repair procedure, right? And one of the things that I used to do as a technician is the first thing I would check if I had a situation where the unit wasn't powering up, I would check the outlet, right? Check the AC, make sure there is AC coming in. And I know that sounds very kind of simple, very sort of basic, right? But at the end of the day, sometimes it's the most simple things that give us the most trouble, and oftentimes we overlook those simple things. So if you establish a system that you standardize, okay, check number one, check the outlet, check number two, you kind of follow what I'm saying, right? Then it allows you to be consistent in your workflow, and of course that's going to give you better results. Customers are happier, everybody kind of wins. All right, so that's just to start off, that's kind of some of the benefits that I wanted to mention. And now let's go ahead and really dive into looking at the schematic. Now, if you look at this, okay, I'm going to kind of zoom into this and sort of navigate around here. I mean, you see a bunch of wires and symbols and letters, and by the way, this is not even the full schematic. This is most like part of the data. But what we talk about is the difference between AC and DC circuits. Okay, so AC circuits is or AC rather, stands for alternating current, and that's typically the 120 volts that you get from your outlet, right? So you go to your outlet where you plug in anything from a lamp to a TV, that's 120 volts AC, and you can usually measure that accurately with a multimeter. This voltage is used to power up high power loads. So for example, again, as I mentioned before, your line input, your voltage input, that's AC. Your water valves, right? These are the solenoids. These are also AC driven. And things like a heater or a pump, that's going to also be AC. Okay, so anything high power is going to require alternating current. Now, with direct current, which is DC, all right, DC is typically somewhere between 3 and 24 volts. Now, in this particular schematic, I don't believe we have anything that's 24 volts. I think the highest voltage you're going to see is 13.5, which goes to the user interface. But again, DC voltage is low voltage. It can't really hurt you. I mean, you can get a little whack from it if you touch it, but nothing major. And this voltage comes directly from the circuit boards. Okay, so unlike AC circuits, that the voltage is generated at the right external house, the DC voltage, there's no external source. Any DC voltage that you find on pretty much any appliance is going to be generated at a circuit board. So there's going to be, filters. There's going to be capacitors. All that. You don't have to worry about any of that. We're just going to talk about the actual voltage measurements. But I just want you to know that if you ever have a DC failure, it's typically as a result of something on a board. All right, we'll get into those details a bit more later on. All right, with that said, direct current, couple examples. One of them is your thermistor, right? Your water temperature sensor is a DC driven component. It's typically somewhere between 3 and 5 volts. And another another component within the board that is DC driven as a communication device. It is your pressure sensor. And this gives us a great opportunity to zoom in over here and take a look at something really cool about the pressure sensor. So we're really zooming in a second. In here, the wiring diagram, schematic diagram, gives you some information about measuring voltage at the pressure sensor. It tells you if you want to measure output voltage, connect your probes between pins 4 and 3, which is your grounding output. This will essentially tell you what the voltage is, depending on how much water is in the washer, right? So a little bit of pressure gets created, the sensor detects it and outputs a voltage. And of course, there's a chart somewhere that you have to refer to if your pressure is good or if it's not. And with that, you can determine why that's like that. A lot of that has sensor. But the point here is not that. The point is that you can measure that between pins 3 and 4. But in terms of what I was saying before about safety, look at what this says here. Shorting pins 3 to 2 will cause the main board to shut down. Okay. Now I don't really know what that means. I don't know if it means it's going to shut down for 5 minutes, if it's going to shut down permanently, if it's going to fry the board. Guess what? I'm going to find out. So I'm not going to show those two. So me reading that schematic and taking a look at that important note can prevent me from having to potentially replace a main board. So that's where we talk about safety and, of course, damaging the equipment. Okay. All right, my friends, I'm going to pause real quick. Questions on the chat, or if you want to just run quickly, feel free to ask a question. All right, Cordell Brown. So yes, sir, please unmute yourself and go ahead and ask your question. Thank you for joining us. And Cordell, I see your hand up, so I believe you might be muted.
Can you hear me?
I can hear you, yeah, just very faintly. So if you can get a little bit closer to the mic, that'd be great.
No, but can you hear me?
Barely, my friend.
Okay, I'm going to use it.
Oh God. Andy, are you able to hear him? I'm sorry, maybe I'm just the only one.
No, just barely inaudible.
Yeah. Okay, go ahead. You could type your question, Cordell. I can read it here. So we're gonna look at it in the chat. Okay. Later, so you're speaking. Okay, so do me a favor, Cordell, if you want to just type your question, I'll get back to it. When about the chart for use. Okay, so you're wondering about the chart for using the pressure sensor. Yes. So in the schematic diagram, so that's a good point. In the schematic diagram, there is going to be a voltage chart that is going to tell you if you have X amount of voltage, it is going to be, only 1 inch of water. If you have X amount of voltage, it's going to be 4 inches of water. And we can actually look at it. I just have to find it. I have to kind of zoom in. So I'll actually pull it up on Smart HQ in a minute because I do have the schematic here. But yeah, there is going to be a voltage chart, and that's why it is important for you to be able to measure that. Okay, but great question. I will definitely get back to when I show you the schematic on the Smart HQ application. Great question. All right. Let's see. So Andy, if you could do me a huge favor, just let me know if there's any questions, because it's a little bit hard for me to go between the two computers. I appreciate it if you.
I'll do that.
You just pause. Awesome, man. Thank you. Thanks, everyone. All right, let's go ahead and move on. Again, a lot of really cool information. So now that we talked about the difference between AC and DC, let's talk about the major circuit boards that live within this washing machine, okay? And of course, those are going to be your main control board, your inverter board, and of course, your user interface. And just to kind of give you a high-level overview of what these three boards do, the main board, of course, controls every major component, right? Your drain pump, your water valves, all that cool stuff. But it also has a very important function, and that is to send 120 volts AC to the inverter. So here's our first kind of piece of information that some of you might know, some of you may not know, right? And this is when we get into the washing machine's not spinning, change out the motor, change out the inverter. It could very well be the main control board that's not sending voltage. So before you start swapping parts, listen to everything I'm going to say today, and then make a determination afterwards. But again, we'll get back to that. Now, the main board also communicates with the inverter via DC line signals. Okay, so there's also DC voltage, but also communication. We'll get into those specifics. The inverter board. What does the inverter board do? Well, it drives the washer motor, and basically what it does is it takes that 120 AC that comes in from the main and converts it into a variable DC voltage. Now, you can't measure it, okay? So there's other ways to troubleshoot, but that's what it does. It takes AC and somehow magically within its circuitry turns it into DC, which is what makes that washing machine basket spin. And of course, the user interface is what brings everything from the outside world. So from the touch commands, right? From the consumer, from you, whenever you press a key, whenever you turn the jog dial, all that information is brought in through the user interface into the main board. And what the main board does is it provides 13.5 volts DC to the UI. So anytime you have a dead UI, before you swap it out, make sure that you check to see if you have 13.5 volts DC coming from the main, because it could be that, or it could be a wire harness issue as well. But I've seen a lot of technicians, believe me when I tell you this, I've seen a lot of techs, dead UI, change the UI board. That doesn't fix it, okay, then change the main board. And then finally it fixes it. But all along it was just the main. They just didn't troubleshoot, and you put in two parts. And again, sometimes, yeah, it's a bad UI and you swap it out and it works. But that's sort of what leads to the bad behavior of swapping out parts without troubleshooting first. Okay, so that's kind of what we're trying to avoid over here. So let's go ahead and show you now a little bit of a closer view of the, before we get into the actual schematic. The schematic is easy, okay? It's just a bunch of wires, lines, and letters and numbers. But understanding how to place or how to go from reading a wiring diagram, a schematic diagram, and actually taking your multimeter leads and placing them on a control board, that is the true art here. That is the true magic. And that's what we're going to talk about here so everybody understands it. So here's a close-up of the main control board. And we're going to sort of just highlight some of the AC circuits. I'm going to label them in red because red is hot. It's like, like high voltage. So, these are some of the AC circuits, connectors, not every single one. And if you notice one characteristic about the AC connectors, they're kind of big, right? They got big pins. They have wider spades on the pins. And of course, they drive higher voltage components, right? Whereas DC circuits, these are the ones in blue. If we sort of zoom in over here, you'll notice that they have many more pins, but they're skinnier, right? And those are the skinnier wires that you'll typically see. And of course, we can't forget our very important pressure sensor right there. There's your pressure sensor, which is the one that we talked about. And let's see if we can get a close-up shot of that. So think about placing your multimeter leads across, across these pins, right? It could be a little bit difficult. And sometimes if you have the thick, meter leads, they can short out pins. So that's why you have to be very, very careful here. With that said, my friends, we're going to focus, I don't want to overwhelm you with every single connector, okay? We're going to focus just on two connectors to start out, okay? And the reason I'm picking connector J512 and connector J514 is because these are the connectors that actually drive your drain pump and your water valves, all right? So that's the two we're going to start with. And these are both AC driven components, right? They use 120 volts AC. And the components themselves have a resistance associated with them. So let's go ahead and take a look at that. And that basically takes us into AC signal path and wire colors. So if you look at this part of the schematic that I've sort of taken out of the larger picture, this is just a small chunk that places emphasis on the connector that goes to the drain pump and the connector that goes to the water valves. So if we take a look, let's zoom in over here a little bit. Connector J512, so it's going to be basically labeled with the number of the connector, is going directly, if we follow the lines, to the drain pump. Now, one thing to notice here, my friends, is on your schematic diagram, you are not going to have these nice pictures. I've put them in there just so that we can understand what they are. The drain pump is going to be labeled with a little box and the word drain pump, and then, of course, the valves, the same thing. In your world, it's just going to be a schematic symbol, lines, and of course, you'll have to identify the connector at the board. So let's, again, I like to zoom in case you're watching this on a phone, on a smaller screen. There we go. So if you look at the symbol over to the left, again, connector J512, that's how we identify all our connectors, with a J. Other companies identify them with a different letter. We use a J for whatever reason. I'll find out someday. But anyway, it is a 6-pin connector because it's labeled number 1 through 6. And I can see that there are going to be 3 wires attached to it. Okay. The wires are going to be attached to pins number 2, 3, and 5. The other pins, 1, 4, and 6, are empty. So when we actually look at at a real washing machine, you're going to see those pins without anything attached to them. It depends on the model as well. But if you look over the picture of the right, there's the actual connector. And a lot of people ask me, "Hey Juan, how do you identify pin number 1? Because I want to try to troubleshoot, but I don't know if I should put start on the left, start on the right." So here's the easiest way. If you take a look at the connector itself, there's going to be a little tiny triangle in most of them, and that triangle identifies pin number 1. Of course, the one next to it would be pin number 2, and so forth. There may also be a number, like a number 1, 2, 3, something labeled, but in most cases there isn't. There's just a triangle. Find the triangle, and you found pin number 1. So now with that said, let's talk about the color of the wires, because a lot of the times you're not going to be really looking at pins. You're just looking for the 2 color wires. So in this case, we can see that connector J512 attaches to the drain pump using a line wire and a neutral wire. And the line wire says C20. Okay, it says C20 right there. So again, kind of zoom in here. You see the C20 and the neutral is B20. If we look over at the table, the color table, which again is part of the schematic diagram, you're going to notice that C is actually brown. I think they say that because it's that chocolate. I think that's how they explained it to me. And then B is going to be black. So essentially you have a black and a brown cable going from the main control board to the drain pump. Now, the number 20 is identifying the wire gauge. So it's going to be basically a 20 gauge brown wire and a 20 gauge black wire that connect the drain pump to the main. Now, in your world, it is not going to look empty like this. In your world, it is going to look like this. Okay, you're going to have the connector, and there's your pins number 2 and 3. And that, if you wanted to measure, let's say, voltage coming from the main to the drain pump, which is probably the easiest way to troubleshoot if you're getting power to the drain pump, you just put your multimeter leads between the brown and the black wire, the ones that are next to one another, and voila, you should get 120 volts. Now, how are you going to activate that drain pump? Well, there's a couple different ways, right? Because at this point, you have the unit all opened up and everything. You can start on the drain pump. That's the first thing that kicks in. You can go into service mode by turning the jog dial, pressing key code sequence, and then select the drain pump test. The easiest way that I like to do it is using Smart HQ service. And that's why it's such a powerful tool, because this allows you to have your multimeter leads on the control of the drain pump. Then turn on the drain pump with Smart HQ, and boom, the 120 volts comes up. Now, if it doesn't come up, then you have a dead board. If it comes up, then your board is good, and if the drain pump's still not working, you have either a bad drain pump or a bad wire harness. So that's one of the advantages of having the Smart HQ service tool. But again, you can do it both ways, with or without it. With it, it's just a little bit easier. Okay. So with that said, I'm going to go ahead and I'm going to quiz you here for audience here. I want everybody to participate. So let's go ahead and dive in and sort of zoom in here to the water valves. So you can see that the water valves are connected to connector number J514. And connector J514 is a 6-pin connector. In this case, we can see that pin number 1 is what's common to all the valves. Okay, so if we kind of follow that line, we already know what C stands for. C is brown. So that brown wire provides line voltage to every single one of the water valves. Now, on the other end, there has to be to complement the circuit, there has to be a neutral. And those come from the rest of the pins on connector J514. And the way that you identify those is not just by the pin number, but also by the color. So if we look, let's do the easy ones, right? The bleach and the pre-wash. If we look at the bleach, it's an N20, and the pre-wash is a Y20. And going to our table, we can see that N actually stands for blue, and I believe that means because it's navy blue. And why, that should be pretty easy. It's yellow. So essentially we have a yellow for the pre-wash and a blue for the bleach. And again, in your world, it is not going to look like that. It is going to look something like this. All right. And if we zoom in, take a look at this, my friends. First, let's look at the connector. Okay. So the connector says for the pin number 2, it's W. Pin number 3 is R for red. And then if we look at the actual connector over here, take a look at this. Your line is your brown cable at the top. Your pin number 2 is white, then red, blue, yellow, just like the schematic diagram shows you over here. And again, if I wanted to measure voltage, let's say hypothetically speaking, I just wanted to measure voltage between or voltage going to the pre-wash valve, just for the sake of argument, I would go between the brown wire and the yellow wire over here. I would place my multimeter leads with the connector in place and activate the pre-wash valve, and that would give me my voltage. And that brings up another point, my friends. When you activate the water valves, again, if you're trying to pinpoint an exact water valve, that is going to be hard to do unless you go into the service mode. You can't Smart HQ, just like hot, whatever it is, boom, press it and it activates it, and you hear that little buzz, bzzz, and that means you got 120 volts. Right? That is how you look at those two particular ones, and this helps you troubleshoot a no-fill situation, a no-drain, those kind of conditions. So let me pause here. Any questions? And grab a drink as well. All right, let's go ahead and move on to DC circuits. DC, my favorite because they don't hurt. So we have a question over here, Cordell. Let's see. So this HQ module is the one that connects directly to the machine. Yes, my friend, the Smart HQ service module. Let me see if I have one. I usually have one laying around here. Oops, I didn't bring one. I usually have one, but today the focus was going to be, but it's a Smart HQ service box, right? I showed it in the picture earlier. That connects to the appliance. You connect it to the RJ45 port, and it immediately allows you to turn your tablet, your phone into, per se, a remote control that you can activate any component on demand. Okay, and we're going to have a demo of it at the end of the presentation, but I wanted to obviously cover all the schematics so everybody understands this. Okay, and I think I saw something else pop up. Yay! So we get this. All right, cool. All right. So let's go ahead and move on to the DC circuits now, my friends. And here we go. So DC circuits are easily identified because they go, again, it's typically like skinny wires. And the ones that I can best show you is the DC communication between the main and the user interface board and the main and the inverter. Let's start first with the communication between main and inverter. Okay, and again, I like to zoom in case you're watching this on a cell phone. So if you look over here, connector J615, that is going to be attached to the main control board. Okay, and you're going to clearly see it labeled 615. It's going to have those letters silk screen onto the board. That goes to connector J101, which is going to be on the user interface board. Okay, now one thing about these two connectors is that they are not the same. They're not the same connector. Obviously, they don't have the same number of pins. Connector J615 has 9 pins. Out of those 9 pins, only 4 pins are utilized. Okay, and those pins are 2, 3, 4, and 8. And connector J101 is a 5-pin connector, which 4 pins are utilized. 2, 3, 4, and 5. Pin number 1 is empty. Now, one of the easiest things that you can check here, again, my friends, I encourage you to do this. If you ever have a washing machine that the display is dead, right, and you're trying to touch it, and nothing's happening, it's not coming up alive, but you got AC voltage coming into the, from the outlet, check to make sure that the main control board is supplying 13.5 volts DC to the inverter, because that could be it, right? And the way you do that is you identify the pin that has 13.5 volts. In this case, it is this wire over here. If you go from the main board, it's going to be pin number 8, and it is a black wire because it says B22. And if you go from the user interface, it is going to be pin number 5. But again, having the color of the wire given to you by the schematic makes it so much easier. Now, what is your ground? Your ground, because for any DC voltage, you have to have a ground. Your ground is actually on pin number 4 on the main, which is, it says R22. It's a red 22 gauge wire, so it's going to be a little bit skinnier, and that goes to pin number 4 on the user interface board. So either you place your multimeter leads on the main board, go to connector J5, 615, pins number 4 and 8, or you place your multimeter leads on the user interface board, pins number 4 to 5. Either way, all you're looking for is a red and a black wire, and that should give you your 13.5. It doesn't really matter the, how could I say this? It doesn't matter like which lead you use. If you turn them the opposite way, you're going to probably get about 13 point, you're going to get 0.5, but it's going to be negative. If you put them the right, I've seen for that at the factory they messed up and they turned the negative into a positive. Never seen that. So you're always going to get the 13.5. The point is, do I have 13.5 volts going to the UI? If you do, then that's great. That means that you have a place the main. Now, you could also have 13.5 volts DC at the main and not at the UI, and that would be indicative of a bad wire harness. So it's a good idea to always ohm out the harness for continuity and make sure that whatever is going from one place, it's getting to the other. All right, that's an important thing. And now let's go ahead and, before I move on. So you see there's 2 pins, right? There's that GEA3TX and then the RX. These are transmit receive communication lines, and they're on pin number 2 and 3 of the connector on the main. You cannot measure these, okay? And the reason I say you can't measure them is you can't measure them with a regular multimeter. If you put your multimeter across those pins and ground, of course, you're going to get some kind of a jumping voltage between, I think, like 2 and 4 volts. It means nothing to any of us. What you would actually need is an oscilloscope to look at a square wave, but we don't carry that around. So there's no way for you to check communication. That would be something that you really can't measure. So we're giving you the information that you can actually utilize. Anything that I mentioned that you can measure, it's unfortunately not going to be able to be tested with a regular multimeter. Okay, I just wanted to make sure everybody understands that. So with that, I want to move on to the communication between the inverter and the main. And this one's actually really important because this is what's going to drive your motor, not just the voltage, but actually the command signals coming from the main to the inverter. So let's start with the basic, the easy ones. And you can see that connector J601, that's the main board, and connector J301, that's the inverter. And one of the easiest things we can check is your 5 volts. There's that red wire, again, because it's labeled R22. That means it's a red 22 gauge wire that goes from connector 601 to connector 301. Now, the nice thing about these 2 connectors is that they're the same number of pins, so it's easy to identify what goes to what. Now, as I mentioned before, to complement the 5 volts, you need a ground, and your ground is right here. That's a black wire, B22, that goes from the main to the inverter. Guess what, my friends? If you don't have that 5 volts going to the inverter board from the main, the inverter board is not going to be able to do its magic, and it's not going to drive the. So a motor that doesn't want to work could be as simple as that 5 volts not getting from the main to the inverter. So it's very important that you understand these. Now, is it common? Not really. I haven't seen many of those. But it is one of the possibilities. And this is where I get technicians saying, hey, man, I have a no-spin condition. Now, there's a signal there that is very important that we need to be able to measure and test, which is this bad boy right here, the speed feedback. On the motor itself, there's a Hall sensor that talks back to the inverter, and that inverter talks back to the main, essentially telling the main how fast the drum is spinning, how fast the motor is spinning, if it's even spinning at all. If that signal is not there, the main board is going to say, wait a minute, there's no, I'm not getting any indication, so I'm not going to drive the motor. And of course, that could be either your Hall sensor at the motor, or it could be a problem with the inverter, or even a wire harness issue. So the fact that you can check continuity, okay, between pins 5 and 5 on these two connectors would basically rule out the possibility of a bad wire harness. And that's why I'm showing you this, because it is important. If you just stop working altogether, not because the motor's broken or because you have a bad inverter, but because that signal is not getting to the main, and that means that the main cannot possibly know what's happening if something bad were to happen, like the machine goes out of balance or spins too fast or too slow or something like that. Okay, so that's more or less the function of those, and these are things you can measure. With the exception of the speed sensor or the speed feedback, you can measure the voltages we talked about, the 13.5 and the 5 volts. So with that, let's shift gears over here and talk about resistance checks, okay, resistance values. And again, we're showing the whole schematic here, but I want to place emphasis on just a couple of these components, right? Probably the ones you'll see the most: your motor, drain pump, and your water valves. Okay, and the reason I want to place emphasis on this is because these are things you've probably seen before and you've measured with your multimeter. So where do you find on the schematic the values for this? Well, it's right here, my friends. It's actually in the upper corner, and if you zoom in, you can see that all the resistance values for each component are labeled on this table very nicely there. So it's telling you that your drive motor face-to-face coil resistance is about 3.5 ohms. If we look at the drain pump more toward the bottom, it's 19.5 ohms. Each one is going to be so again, if we were going to go to the top, if you just had a bare motor sitting on your workbench, and you place your multimeter leads between those red, white, and blue wires, you would get about 3.5 ohms, plus or minus, what was it, 7%, something like that. If we were to go to the drain pump, all right, and you place your multimeter leads across those two, you see kind of like the little holes up there at the top, you would get your 19 ohms. And if we move over to the water valves, any water valve, right, that you put your multimeter leads across the pins over there, you're going to get about 1,070 ohms. So that's how we would measure resistance on the components themselves. But again, my friends, a lot of the times you're not going to have the luxury of being able to move the unit at the point of installation, disassemble it, and get all the way to the component itself. So a lot of these times you want to measure directly from the main control board, which makes it easier. Also, it allows you to know if the wire harness is intact, because if you're measuring resistance from the component at the board, that means that wire harness is bringing the resistance all the way back to the main, so the wire harness is more than likely in good shape. All right. Now, to do this, it's actually quite simple. You detach the connector from the board. So in the case of the drive motor, you would detach it from the inverter, and you measure across the pins right there. So across blue to white, blue to red, or white to red should give you about 3.5 ohms, like we said before. In the case of the drain pump, all right, if you detach the cable or the harness from the board, and you measure across those two pins we talked about earlier, pins number 2 and 3, right there. I'm zooming in really close so you can see it. You should be able to get about 19 ohms of resistance. And of course, if we talk about the water valves, if you detach the connector, you should be able to get right there. See the connectors detached? You should be able to get your 1,070 ohms. Now, water valves, I'll be honest with you, they're easier to check right at the valves themselves. But either way, it doesn't hurt to check at the connector, because you can measure you can see if the wire harness is good. Now, very important point I'm going to make here, my friends. If you're ever measuring resistance, please do me a favor, unplug the appliance from the outlet. Doesn't matter which appliance it is, because when you're measuring resistance, if you accidentally connect to a live line, right, to voltage, you're going to blow your meter essentially, or you could hurt yourself or damage the board itself. So that's number one. Unplug the appliance, then you can measure resistance. The other thing is, and again, we're going to go back over here to the slideshow, please make sure that when you measure resistance, you detach the connector. See the drain pump connector? It's detached from the board. See the water valve connector? It's detached from the board. The reason why you want to detach it from the board is because if you measure with the connector attached to the board, you're going to be measuring board resistance, and that is going to give you an erroneous value. It is not going to work. Okay, I've seen this time and time again. Technicians go to measure. I tell them, measure the resistance at the drain pump, and they measure with the connector attached to the board. They're like, yeah, I'm getting like 1,000 ohms. I'm like, there's no way. The drain pump is not 1,000 ohms. They're like, yeah, that's what I'm getting. Then you're telling me that we have a bad drain pump. Once they detach it, they're like, oh, now I'm getting my 19 ohms. So the drain pump is good, but something else was causing it to fail. So again, detach the connector from the main, and you'll have no problem whatsoever. All right, that's how we would measure resistance at the components. All right, let's go ahead and move on over here. And now let's bring it all together, my friends. Now let's talk about how to troubleshoot a washer machine that's not spinning or that is not agitating. This, right? There's seven things. Go through them in detail, right? So we're going to bring it all together. So the first thing that we need to know is what are the components that drive the motor? Well, you got your main board. I already said it before. You got your inverter and your motor. These are the main three things that make that motor spin. Now, with that said, the main board supplies 120 volts AC to the inverter, but only when the motor needs to turn. Okay, that 120 volts is not going to be supplied at all times because that would be a waste of energy. It is only supplied once the machine goes into agitate or spin action. All right, so very, very important that you understand that concept. Now, there's communication between the main board and the inverter. We kind of talked about that earlier before. What was it? The speed signal, the 5 volts DC, all of that. And then there's also going to be voltage that's generated at the inverter, which is DC voltage to drive the motor. Now, you could forget about measuring that because there's no way to measure. There's no known value that you could take a multimeter and put it there, but I'm just letting you know there's DC voltage coming from the inverter to drive the motor. And at the same time, the motor, as it's spinning, is going to feed back signal, all right, through the Hall sensor, is going to send the signal back to the inverter, which essentially is going to also go back to the main board, telling it how fast it's running. So that's your RPMs. Now, if any of these fail, guess what the symptom is going to be? No spinning action, all right? We already talked about the resistance at the coils of the motor. That's one of the first things you should make sure it's good in terms of the one. So if you take your multimeter and you measure the resistance and it's 3.5 ohms plus or minus 10%, and again, it depends on the motor. So always look at your schematic, look at the table and schematic diagram. Then that's going to give you whether or not the motor is good. The other thing you want to check is 120 volts AC going to the motor from the main? Here's how you do it. So on the schematic diagram, it's going to clearly tell you that, if we kind of zoom in here, okay, it's going to tell you that connector, let's see, 506, J506, goes from the main all the way to the inverter right there. Let's take a look at how that actually happens. So if we zoom in over here, there's your connector, and connector J506 on pins number 2 and 3, there's your inverter neutral and your switched AC line. It's switched because, as I mentioned before, it's not always on. It's only on when the machine calls for spin or agitate. And of course, you have a ground on pin number 1. On your board itself, the way you would measure, you would put your multimeter leads right there. So there's the connector right there. You would put your leads between pins 2 and 3, which is your line and your neutral. And then you would activate your motor. Okay, you would activate either the spin action or the agitate. And what you should get on your multimeter is 120 volts AC. So it's going to go from 0 to 120 the minute that you activate a spin or agitate action. Now, all of this is going to happen while you're with the machine. You have the whole thing open. You have your meter leads on that connector. What did I say? 506, I believe. Pins 2 and 3. You should be measuring 0 if the machine is not spinning or agitating. Then you can go to your control board, either activate, spin, or agitate through mode or hit the start button, whatever you want to do. And then you should see your multimeter switch from 0 to 120. That means you got voltage going from the main to the inverter. You don't get that voltage, guess what? You have a bad main, and that's what you would need to replace. If you do get that voltage and your resistance coils are reading the right resistance on the motor, then and nothing's happening, more than likely it's your inverter board. Could it be your feedback? It could, but there's no way for you to measure it with a meter. That's where Smart HQ service comes in. Okay, we'll get to that in a minute. But there's also one more component we haven't talked about here. Okay, there's one more component that we haven't mentioned, and that is your accelerometer. All right, and your accelerometer, my friends, is the board that is attached to the top of the tub that detects when the unit goes out of balance. Now, this board itself, if we kind of zoom in over here, it receives 5 volts, and you can see which pin it is. I don't need to tell you anymore because we already kind of went through this, but connector J901 on the main supplies that 5 volts to connector J301, which is the connector on the accelerometer itself. Guess what? No voltage, you're going to have a fault code related to the accelerometer, but it's not your accelerometer. It's your main that's causing that. If you do have voltage and you get a fault code related to the accelerometer, then more than likely you have to replace the accelerometer. And that's why it's important to know these symbols, these signals. Essentially what you would do here, my friends, is you measure between pins 1 and 4, and that would allow you to see if you have your 5 volts going from the main board to the accelerometer or not. Okay. And again, looking at the wire colors, I didn't label these or I didn't paint these, but you can clearly see that you're talking about a red and a black wire because, for example, on connector J901, pin number 1 is R20. So a 20 gauge red wire. And pin number 4 is B20, a 20 gauge black wire. And they go to the connector on the accelerometer, your ground, and your 5 volts. So that is how we would essentially, whoops, check us out over here. Okay, here we go. That's how we would measure all of that information. And let's go through this again. Get to that slide right there. Now, in your world, my friends, it is not going to look, again, the schematic diagram is not going to look like, oh, it is going to look like this, but in your world, what you're actually going to measure is at the board, you're going to look at something like this. Take a look. See how simple it is? There's my 4-pin connector, and it's black, yellow, blue, red. And the way you identify that, the pressure right, that black sort of tube that's sticking out from the board, that's your pressure sensor. That's where the hose gets connected. And very important that you check that hose because sometimes that hose can get pinched, can get a little cut. Something as simple as that will cause the machine to give you all sorts of trouble. So you have a lot of work to do. Okay, there's a lot of things that you have to check. But at the very least, I think we've covered the schematics to a point that you should have a better understanding if you didn't before of how to follow the symbols, how to follow the lines, identify the color of the wires, and how to leverage that information to physically use your multimeter to measure resistance or measure voltage, because that's ultimately what the schematic allows you to do is know if you have good resistance, if you have good voltage, and if you don't, which parts to replace. Okay, so let me pause here to see if there's any questions on the line. I see some folks are joining a little bit late, so we'll have
hello.
Show. Yes, hello. Thank you. Yes, thank you for joining us.
I'm very sorry. I got on late. I couldn't, for some reason, wouldn't let me on.
Don't worry. We have another session at 11 a.m. Eastern time. So if you have time to join, and if not, I believe this is being recorded. It's going to be on Encompass's YouTube channel. So
okay.
I wouldn't worry about it too much. Okay, my friend. But either way,
well, I got a couple questions for you. I'm having problems with one of these GE blue gasket, front loaders.
Yep. Okay.
So I changed the main board because I wasn't getting voltage down to the change the board. So I did. I changed the board. Customer called me back a couple of days later, said it's doing the same thing. So my question to you is, when changing these boards, should we change the pump also?
No, I don't recommend that. Just came on the call.
Yeah,
The
I
second we
just
talked
caught.
about.
Yeah, I just
Yeah,
caught the tail end of you checking for power.
yeah.
That's why I apologize.
No, no worries. So I encourage you to join the second session. We go into detail about checking resistance, continuity, and voltage. You have to check those three things because if one of those is not there, that'll basically tell you which is apart. There's really no magic to a drain pump.
No, I know. Yeah.
It's a drain pump, the main, or the wire harness, and of course, physically, any obstruction that would be beside the point because that's not an electrical issue.
Yeah.
So yeah, I definitely encourage you to join the other session, so you can see in detail. Because it would be a lot for me to explain. We don't have much time on the call left, but yeah, if you can join it, then you'll understand that fully, as well as other components as well. So definitely, feel free to
Now,
join.
when you, sir, where you, what's up?
And it's freezing
Okay.
over here, so maybe Andy's. I'm jealous of Andy. He's in nice Fort Lauderdale. Nice
So you know,
Mid 70s today.
Yeah. Rub it in, rub it in, man.
Let's move on. Corey, go ahead and speak. Open your mouth.
To check the motor ohm, you would need to get to the inverter, not the main. So maybe I misspoke somewhere there, but you were absolutely right, Matt. To check the motor ohms, yes, you would need to detach the inverter does connect directly to the motor. So if you want to check the inverter connector, detach it from, sorry, the motor connect the inverter board. This is going to be the main. Peter, in my experience, the pumps on the blue gasket unit appear over amp and below the board. I always change the pump too. So here's another thing, my friends. There is a service bulletin. I'm going to bring it up right now. Okay. And that's why it's so important to have the Smart HQ service tool. Take a look at this right now. Inverter board diagnosing. I can't find it right now, but on Smart HQ service, there is going to be, is there a training bulletin? So you can see right here on Smart HQ service, there's all kinds of information, board bulletins, training bulletins. Oh, not draining. There we go. Right here. Ultra fresh washer, not draining. Check for your resistance. And I won't go through the whole thing, unfortunately, for the sake of time, but one thing that it's asking you to do on the board is check the main board for damage at Q553. So you're looking at this right now. I'm just pulling this up from the app, which is why it's so important. Now, it's clearly telling you if the main control board has a failed component, so that transistor right there, that Q or whatever it is, yeah, I guess it's a transistor. Verify the wire harness is not shorted to chassis and replace the drain pump first, then replace the main board. So this may answer the question that you brought up there, the gentleman before, because if you just swap out parts randomly, you're going to fry that board over and over again. And this bulletin gives you the information. So that is super, super duper. The other thing I want to bring up before I forget, because somebody asked, is on the schematic diagram over here, there is a chart for that pressure sensor. And it is right here. Okay, so somebody was asking me that pressure sensor, right? How do you know how many inches of water are dependent on the voltage? Here it is, water level, normal wash, 1.8 inches. The voltage is low. If you have more inches, like the overflow, 11 inches, the voltage would be 2.32 volts. So I wanted to make sure I cover that because somebody did ask that earlier and I did not want to miss it. Let me take a look at the other questions over here. If I have a DC motor, how can I test it? If power is going to it or for quality, say periodic issue. If I have a DC motor, so that is a very open-ended question. There's different ways you could test a DC motor. Nothing that we're really, oh, a fan. Okay, so fans. So we are going to do some courses on units that use a fan, but essentially fans are typically driven with DC And the same way that we check, for example, the voltage going from the, so let me go back over here to kind of show you. Okay, so right now we're checking the voltage going from the main board to the accelerometer. So we have pin number 1 on J901, that is your ground, and pin number 4, that is your 5 volts. Think of the accelerometer as a fan. If it was a fan and you want to measure DC voltage, you would go from voltage to ground. Again, there's also speed signals with fans, but we'll get to that when we get to something like refrigeration, all right? But I definitely just wanted to make sure that I just mentioned that really quick over here. All right, my friend.
Scott had a question. Scott, speak openly.
Yep.
Hi. My question is routinely I'll run into one where you power it up, start it, and it will run for about 10 seconds and then go to the end, and it's the end of the cycle. Where would you even start with that?
So you're talking about a spin, like a machine spinning. It starts to spin and then it just in 10 seconds stops, like it's over, the cycle's over?
No, I mean starting the cycle from the beginning. You power it on, you select your cycle, you mash start, and within 10 to 15 seconds it says end across the display, the door unlocks, and your cycle is done.
That's probably a software related bug, which would require you to either update the software. Again, you can update it using Smart HQ service. You can do an over-the-air update if the customer has the unit connected to Wi-Fi. You can order a sum module. Easiest way is through Smart HQ service. Or if there's no software update available, you probably just have a corrupt board. That's what would cause that. Something else that you want to look for, though, before you do that, my friend, is check for error codes. There could be a component that is causing that, and I can't think off the top of my head which. It could be the accelerometer, it could be the door lock. But if there's a component that is preventing the machine, and a lot of the times it's your door lock, from preventing the machine from actually running through a full cycle, it is going to immediately throw an error code. Again, you need to go into service mode to pull up that error code. But that would be the only thing that would cause that. And more than likely, I'm going to venture to say it's a corrupt software which needs an update for that specific situation. But that's a great question.
Awesome.
Thank you for asking.
All
right,
Hattie,
awesome.
Hattie's had a question. Go ahead and unmute. Hattie?
Hello.
Hello.
Asking. Yes,
Yep.
Go ahead.
Can you hear me?
Yep.
Yes.
Yeah, thank you so much for holding this class. I'm learning a lot today, I'm telling you. And
We're glad to know that. Thank
hopefully
you.
everyone is learning. But my question is very simple. The color coding on the wirings, is it the standard, coding, or will it apply to all appliances like washer, dryer, dishwasher?
That's a great question, and I'm so glad that you asked, Hattie. Okay, the color code is different from manufacturer to manufacturer. I've worked for other manufacturers as well, and it's different from machine to machine. Okay, so always look at the wiring diagram on the schematic. Look at the table on the schematic diagram. And I recommend don't go always by the color. Don't 1,000% trust the color. Go by the pin numbers. Okay, the pin numbers are more important because I've seen, not with GE but with other OEMs, that if at the factory they run out of a spool of yellow wire and production needs to continue, they have a spool of red, they're going to use that spool of red wire to finish the products that they have to push out of the door. I have seen it happen, not with GE but with other OEMs. So that's why very important to use the pin numbers instead. I go by the pin numbers always. Are you going to match the colors with like GE appliances? Have I ever seen a problem? No, never. I've never seen one just yet. But just to be on the safe side, the best way is pin numbers. But great question. I'm glad you asked that. That is an excellent point. Thank you.
Yeah, the reason for this question was I was working on some other appliances, other brand, and the color started from blue at the main board, and if you go to
yeah, sometimes there's a connector between. I don't know why they do this. The color changes. Maybe just to give you technicians a hard time, but it's a reality of this business.
Thank you for answering my question anyway.
My pleasure. All right, my friend. So the last thing, so there is going to be an in-house training. You have to reach out to Encompass. because unfortunately, for example, the speed signal, right? There's no way you can measure that with your multimeter. We talked about the motor to agitate the spin right. There's no way that you can do that by going into the service mode. But watch what I'm going to show you right now. How with Smart HQ service you can actually bypass any and works or doesn't. And this is going to blow your mind. It's actually pretty fascinating. So tell how we're going to the motor. So to work the speed and determine if the motor get up to the top bar. Take a look. Is amazing. Right now, my friends, is how you can run a spin test right from your application and essentially ramp up the speed on the motor and graph the speed, right? So we're going to see two things. We're going to see the target speed. We're also going to see the actual basket spin speed. Spin action on. And now you're going to see that basket begin to spin, first slow, and then it's going to really get up there. Now, when you do this, my friends, do not do this with the door open, okay? I'm a trained professional in a controlled environment. So this tells you right now that the machine is capable of going up to 800 RPM at the very least. But as soon as it gets comfortable, right, the stakes are going up. Whoa, look at that, 1100. What we just did right is we were able to spin test by utilizing Smart HQ service and verify up to the maximum target speed. That's extremely important. That's going to speed. It's not able to squeeze the water out of those clothes. How that the speed that I said that you can't do with a multimeter, you can actually see it in real time with your Smart HQ service application. And it's such an important thing because if that Hall sensor on the motor is not actively sending signal back to the inverter and then in turn back to the main, guess what? The motor is going to stop right away because there's no way for the main to be able to control what's happening on the other side. And this is where technicians run into, I replaced the main, I replaced the inverter, I replaced the motor. Eventually it worked, but I had to change a bunch of parts. When in reality, you just needed to change maybe one part, and you spend a lot of time and effort and money, which can be costly. And the thing about parts, my friends, whether you use a schematic diagram or you to troubleshoot or you use Smart HQ service, the less parts you use, the more competitive you become in your field because you're able to fix the problem. You're still going to fix it, but with less number of parts, which means less dollars for your customer, right? Your labor is going to be the same, but you're going to charge less. And when your customer goes out and, decides who to use as their service company, if you come in less with your quotes, they're going to go back to you because you fix it anyway, but you fix it at a lower price. It makes for a wonderful thing for everybody. Okay. So my friends, unfortunately, we are out of time. Let me answer these last couple questions. Let's see. So somebody's asking the accelerometer. The accelerometer is on, if you take the top cover off the washing machine, first thing you'll see on top of the tub is a little board. That's your accelerometer. So right on the top. It says Google, the bottom near, no, it's on front load washers is going to be, it's going to be at the top. Okay. And, Hattie, you had another question. So if you want to just ask the last question that we'll be able to take for this session, go ahead.
Thank you. Thank you. Thank you. Can you hear me now?
I can hear you. Yep.
Yeah. My question is, sometime I do struggle to find the point where to connect the jig, especially on the refrigerator. I never found that. Trust me. But I able to find, if you have anything anywhere we can see and go there and find where we can connect on all appliances all together so we can train our technician as well.
So I'm actually going to share, let me see if I can, IBM. All right, I'm going to put a link in the chat box, and I want everybody to copy this link. This is our on-demand training. This is independent from what we're doing with Encompass today. In this link, it's that video that I just showed you before, the one with the spinning motor. That's just part of a whole training that we have, and we have a ton of other trainings. click that link, save it to your favorites, watch those presentations anytime that you have a free moment. It is going to teach you a ton of things, where the connectors are, all that good stuff. Okay. So you're gonna be able to learn a lot from that. Also, we're basically done with the class, but I'm gonna leave you with the QR code that you can scan to take advantage of Encompass's offer, which is the Smart HQ Service diagnostic tool plus a month of subscription. You pay $200, but if you spend $2,500 worth of parts in the next 2 months, you get it for free because you're gonna get that credit back. Okay. So once again, my friends, I want to just say thank you. Thank you so much for joining. We have another session at 11. If you missed anything right now, you can come back and join again if you have some questions. But we'll leave you with that. And thank you so much for joining. See you next time, my friends. All right.
Juan, thank you very much. Ladies and gentlemen, thanks for attending.
Go ahead, Andy.
Thanks for attending. Look on encompass.com, and we have our various training stuff there. There's also a link to the GE On Demand training. And thanks again. I appreciate it.
Hey, Andy,
Yes.
will there be in-house training like in Albany, New York?
We have some Albany trainings coming up. Again, look on encompass.com under training. You don't need to log in anymore. You can just hit the training link, and the drop down will show you where they're at and what times they are.
I mean, this was great. Don't get me wrong, but I think if we had in-house training, so
we are trying. It's very expensive to put on in-house training.
Yeah.
We are expending it. It's easy stock, and it certainly has built up a lot of steam. And be frank with you, it used to be just kind of Fort Lauderdale and Atlanta, and we have expanded out west as well as up north there. And they've got that new warehouse, so we're in a pretty good place.
I think that would be. I think the guys would actually pay for that service. The training up here.
I believe we have a sealed system that's a cost, but typically our trainings we don't charge for them. As a matter of we are focused on quality trainings, whether they're virtual or in-house. And the in-house are just a little. There's not going to be as many of them, and we need a full crowd to justify it to the manufacturer. So again, go back to the encompass.com training, and there's typically about 3 months out of what we got scheduled there.
Okay.
There are trainings scheduled in Albany coming up. So definitely go out there and check it. And I'm updating it constantly. So
now who's this? Who am I speaking to?
I'm Lisa. I also help with training with Andy.
Okay. I'm just curious. I was a service tech for G for 35 years. I just want to know. Yeah. Okay.
She's underestimating it. I would not survive without Lisa. And thank her for her efforts in helping put these together. So on that note, I'm going to end. You folks have a good day. And there is another one at 11 o'clock if you want to run over it again. Thank you.
Yep. Have a good day.